Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous video, we built the intuition when a dummy interacts with a continuous variable, the two groups get different slopes. Now let's derive that formally and see exactly where the beta 3 comes from. So let's start as usual with our model where y is equal to beta 0 plus beta 1 x plus beta 2d plus beta 3 x times d plus an error term. We are going to assume that the conditional expectation of the error term on the dummy and the x variable is equal to 0. So that would mean that the conditional expectation of y on d and x is going to be simply beta 0 plus beta 1 x plus beta 2d plus the beta 3 x times d. Okay, so we work with the conditional expectation from here as usual because this removes the error term and it lets us focus purely on the systematic part of the model. Now let's take the marginal effect of x to find the effect of x on y. So if we were to do the derivative of y with respect to x, normally that should give us simply beta 1 plus beta 3d, as here these two terms are the only ones that actually contain the x. Anything else that doesn't have the x obviously disappears, okay? Now, keep in mind the d is treated as a constant, just like we did with the z in the general formula that we saw at the beginning of this mini arc for the interaction term. So the interaction term here, x times d, differentiates to simply beta 3d. Okay. Now, let's evaluate this by group. So this was the marginal effect. So if we evaluate this for d equals to 0, then this derivative is then simply beta 1. Okay, so in the other case, when d is equal to 1, then this derivative becomes simply then beta 1 plus beta 3. Okay, so the slope of x is beta 1 for this d equals to 0, which we're also going to start calling it more often the baseline or the benchmark group. And beta 1 plus beta 3, that is the slope for the other group. And the difference between the two slopes, so the beta 3, is the difference between the two slopes. And I'm going to put slopes in a box, then this entire thing in a box, because this is an extremely important result in here, in this case, okay? So the slope of x depends on the group. Beta 3 is the difference in the slopes. And just as we said in the previous video, if beta 3 is equal to 0, then that simply means if beta 3 is equal to 0, that just means that the slopes across the two groups are the same, because the difference that was supposed to make them different is actually 0. Which means that if the slopes are the same, we have parallel lines. Okay? So it means that the interaction term is literally adding nothing. Now, how does that link to that general formula that we have seen at the beginning of the mini arc? Well, this is exactly the general formula, okay? Because in the previous case, like in the previous video, we saw that the derivative of y with respect to x had just like beta 1 plus beta 3 z, where z was, in our case, like something that we didn't define. It could have been anything, even a continuous variable. Well, in this case, the z is now restricted to being a dummy, taking only values 0 and 1. So it's the same formula that you have already seen. It's just a special case. And this is the pattern throughout the interaction mini arc, as you will see with the other videos as well. Now, what if we flipped the question around? What if we wanted the effect of this dummy? Okay, which would mean, well, let's take the derivative of y with respect to d. In this case, the effect would simply be beta 2 plus beta 3x. Now, the effect of the dummy, so the effect of the dummy also depends on x. Okay? And this is a very important insight, okay, that you might have missed because the gap between groups is basically not fixed. It changes with the level of x. For example, the income gap between employed and unemployed individuals may be larger for highly educated people. Now, the difference between the two groups is not constant. It changes with x, so that also means that the gap between the groups depends on the level of x. And this is why interaction terms are so powerful and why ignoring them when they are present sometimes will lead to misleading conclusions. So keep that in mind. Interaction terms create heterogeneous effects. So the slope of x depends on the group. The gap between the groups depends on the x. There are always two ways of saying the same thing. In a dummy times continuous type of interaction, the marginal effect, as you have seen here, is either these beta 1 plus beta 3d, which means like it differs across the groups, but then it's also either these beta 2 plus beta 3x, which means it depends on the level of x. In the next video, we'll apply this in a worked example and interpret the coefficients step by step. So stay tuned, and I'll see you in the next video.